Our topics for today are hard water, seepage, and permafrost, which two of these relate directly to our lab activity. First of all, key concepts and vocabulary. This is what I'm teaching you today. This is what I expect you to learn. You do not have to copy these questions and answer them in your notebook as I go through the presentation. You do have to take at least some notes to get a done stamp for showing me that you did something. This is not what we mean when we say hard water. It's not solid water like frozen ice. This goes back to groundwater. And remember that as water falls from the sky, it will infiltrate the ground and then it goes down here and will collect in an aquifer. Well, water that is moving through the ground can pick up some minerals. So we wind up with minerals in our groundwater. And when that water comes back up out of the ground, it's not just water, it's water mixed with minerals. That much we know. We tasted some different spring waters and we could tell there's different amounts of minerals in groundwater. So here we've got Perrier, which was water number 1 from our water tasting activity. And most of you could tell that there was a lot of minerals in there because you didn't like the taste. Well, I put some in an Erlenmeyer flask and I boil off the water. And you can see the residue that's left behind. That's a bunch of minerals in the water, as opposed to tap water. When I do the same thing, we don't see that residue. There's not nearly as much minerals in tap water as we see in Perrier water, which comes from the ground. That water with minerals coming up out of the ground can come straight into our house. If you have a well, that mineral water comes into your house and comes out of your faucet. Or if you live in a town that uses spring water or well water for the municipal supply, you could be getting water coming through your pipes that has a lot of minerals in it. But not all groundwater has a lot of minerals in it, because as the water moves through the ground, you could be going through some ground that doesn't have a lot of minerals to give up to the water. So when the water comes back out of the ground, it doesn't have minerals, as opposed to over here, where we've got a different type of ground that will allow a lot of minerals to be dissolved into the water. And this is what we saw in this part of our lab activity. We had limestone, which is very common in Florida with their type of rock, and we shook it in the water and we saw, man, the limestone gave up a lot of minerals. It made the water cloudy. As opposed to granite, the granite was very clear water. Didn't get very cloudy at all, which means granite doesn't give up a whole lot of minerals to the water that passes through it. So let's define this whole hard water concept. Hard water is just water that has a lot of minerals from the ground in it. There's no hard and set number on there necessarily that says this is hard and this isn't. It's more like a scale. That water goes from being soft to being very hard, with kind of a range in between. But for our purposes, we're going to say that hard water is water from the ground that's got a lot of minerals in it. It's not that we just drink groundwater in a bottle that we buy at the grocery store that's labeled spring water. We also have water that comes up out of the ground and goes into our house. So if that water has a lot of minerals in it, then we've got some concerns that we need to look at. Anything in my house that uses water is going to have some minerals in it. So my toilet's going to wind up with a bunch of minerals in it. My sink, my shower, my ice cube trays, anything that has water going through it, if that water has minerals in it, I still have the minerals, especially after the water evaporates. When you flush your toilet and water runs down the side of the bowl to fill it up, well, the side of the bowl doesn't stay wet, but some of the minerals stay behind. So you can actually see a buildup of minerals on things in your house that always have water in them. Like your shower head. Here's a shower head. You turn it on, water comes out, but when you turn the water off, some of the minerals get left behind, and over time they can build up, especially at the point where you can see them. If you have a faucet, a shower, well, those things always end up being a little wet every time you use them. The water evaporates. If you have hard water, what you end up seeing are little spots and streaks, a little residue. And that's the minerals that was in the water that got left behind when the water evaporated. Here's a fancy wedding venue that I went to, and they used groundwater, and it was hard water. It was a fancy place. and it looked like their toilets were dirty. So they had these little signs that, hey, look, please excuse the dark circles in the toilet because it's not that they're dirty, it's from the minerals that we have in our groundwater. Here's an overflow of a sink. So water fills up and it gets too high and it flows out through this overflow valve. And this is a really old hotel. And they had really hard water, some of the hardest water in the country. And over many years, every time the water flows out, it leaves a little bit of minerals behind and it's built up.
So this is a water bottle filling station at Palm Springs, California airport. And this is an area that gets all of their drinking water from under the ground, which means there's a pretty good chance it has dissolved minerals in it, that hard water. And you can see evidence of it here. You can see this kind of scum here when the minerals were deposited on the surface once the water evaporated. You can really see it up there. Now, this doesn't hurt you. It's just minerals. It's hard water because they get their drinking water from under the ground.
Hot Spring, Arkansas. You can see the sign is coated. This is a fountain that's from groundwater. You can see the minerals that are caked all over the place. I showed you this before. That hard water sometimes there's enough minerals. If it's the right minerals, it can make the water smell. Now, in all those previous examples, at least we can see it. But I want you to think about all the places in your house where there's water, but you never ever see that water. Let's look at a tea kettle. You know how a tea kettle works. You pour some water in the tea kettle, you put it on the stove, and when it gets hot, it whistles, and you have hot water to make tea, coffee, ramen, whatever. But you never ever see inside the tea kettle. If you have hard water, the water comes out, but the minerals get left behind and they build up over time. Once again, it's not bad for you, but there are other places in your house where it can be a problem, like your hot water heater. Your hot water heater is a big tank in your garage or in your basement or in a closet somewhere, and it has a bunch of water in it, and it's being heated right now so that when you turn on the shower, you get hot water. Well, if you have hard water, a bunch of the minerals get left behind in the hot water heater. And your hot water heater can actually start to fill up with these minerals, or the heating element. The thing that the water is touching to get hot gets caked in minerals, so your hot water heater doesn't work very well, which means it's more expensive. It's more likely to break. Your pipes are a big deal. Think about this. I made a pipe this wide because that's how much water I needed to get to wherever this pipe is going. Well, now, because of the hard water and all the minerals that have built up, now my pipe is only getting water from a diameter that big. This is a problem. And if the pipes ever totally clog up, well, then no water can get through. Now, hard versus soft water makes a big difference on your hair, especially when you shower. When you shower and you go to rinse your hair and the shampoo goes out of your hair and the water dries up, some of those minerals get left behind and it dramatically changes the characteristics of your hair. And obviously, you want your hair to look and feel a certain way. So people that live in places with hard water have to use a special shampoo that will remove the minerals after they're done washing their hair. This was a good example of what I wanted to show you about how hard water and soft water clean things differently. You put some detergent in and you shook the bottle, and the hard water only made that much suds. The same amount of soap made that much suds with the soft water. Well, in which case did the soap work better? Soft water. So if you've got hard water, soaps actually don't work as well, which means things like your laundry don't seem to get as clean. Whites and colors and such, after repeated laundering in hard water, seem to kind of lose their color. They look a little dingy. They don't look as clean. Now, they're still clean, but here's what happens with the minerals that get left behind. Water basically doesn't like to grab dirt. So we use a detergent, and the detergent sticks to the dirt and it sticks to the water. So when we drain the water from our washing machine, the dirt, because the detergent is now stuck to the water and the dirt goes with the water. However, if you have hard water, your water is already holding minerals, which means it can't hold on to the detergent as well. So when the water is drained, the water doesn't pull as much dirt with it. It also doesn't pull as much detergent. A lot of times when you have hard water and you take a shower and you're rinsing with, you're washing with soap and or detergent, it seems like it's hard to rinse off of your hair, off of your body. And that's true because the water doesn't want to grab the detergent because it's already holding a bunch of minerals. Your dishwasher. Your dishwasher will get clogged or caked in these minerals. And things that you wash in the dishwasher will always have a film of minerals left behind. Is it dangerous? Does it taste bad? Not really, but it certainly doesn't look pretty. So how do we correct this? This is what we use a water softener for. A water softener is a tank. The water comes in, it runs through a kind of a filter that has these pellets in there, these salt pellets that will remove or grab the minerals as the water moves through it. So when the water comes out of the water softener, it is what we call soft. It doesn't have as many minerals in it anymore. In Florida, that's big business because they have a lot of hard water problems. You go up and down the road and you will see places that just specialize in making water soft. You won't find one of these in our area. My parents, who have a well, this is their well in their backyard, and they live in Florida, which has notoriously hard water. So before the water from the well goes in the house, they run it through this water softener, and it takes out a lot of the harmful or excess minerals in the water. Walked into a Walmart in Great Bend, Kansas, and right in the front door they had stacks and stacks and stacks of these pellets that you use for water softeners. And that immediately told me, hey, this is an area that must have really bad hard water. And I actually saw some just being sold at the side of the gas station. It's something that people in the Midwest have to deal with. Here's a hot water heater on the inside with a water softener and without. You notice without, you get a lot of extra minerals being deposited. Same thing on a shower. Now, where do people have to deal with hard water? Primarily in the Midwest and also in Florida. Those are the two places that have notoriously hard water. You go to Great Bend, Kansas, anything that had water running through it, like a water fountain or a spigot, you can see the minerals left behind. Is it dangerous? No, it's just kind of annoying. A couple of fountains, one in Oklahoma, one in Florida. You can see the minerals that are left behind. A spring in Manitou Springs, Colorado. These rocks down here in the bottom were like covered with kind of like a clay because there were so many minerals being dropped into those rocks all the time. People in areas with hard water, sometimes the water softener, they don't like the taste of the water coming out of the water softener, so they will go to these specialized companies and buy their drinking water because they want to have water that doesn't have the excess minerals in it. So we don't have problems here in Atlanta for two reasons. We get most of our water from rivers and lakes and not from the ground anyway. And even if we had a well here, we're on granite, which doesn't dissolve the minerals enough to give us hard water. So why am I teaching you about this? I'm always working under the assumption here that you might not always live in Atlanta for your whole life. Case in point, I had a buddy of mine from childhood, 52 years old, lived in Georgia his whole life. He moved to Ohio and he had a well. This is the well in his house. And he had a double water softener system in his house. And he really wasn't that familiar with it because he had never ever had to deal with a water softener before because we don't have hard water here. So there's my point. A lot of the things we're going to talk about aren't going to necessarily maybe directly impact you, but they might at some point if you move somewhere else in the country. Seepage. Now, seepage is described as being the slow movement of groundwater, usually kind of like an oozing. It's not like an underground river. It's the very slow oozing of water through the ground, usually sideways as opposed to down. Here's what happens. So it rains and water comes down, and remember the ground is not uniform. Some places, let's say if it's pretty sandy or it's more like dirt over here, the water just keeps on moving. But water that hits clay kind of gets hung up a little bit because remember, clay's not very permeable. So you could wind up with a situation like this. The water got into the clay, and then it kind of has trouble getting out. So I can have a little area here where we have more water in one spot. It has trouble getting out or moving where it wants to move. Well, if the ground is unlevel, we got water that kind of gets stuck here in this clay, and it has trouble getting out because it can't move through the clay very easily. And there's more water trying to push its way into the clay. It might be easier for the clay to move out of the ground sideways. That's what seepage is. It's kind of that slow pushing or slow moving of water through the ground, especially sideways. This is Centennial. And at Centennial, we had a really steep hill beside the school, and we had this pond. And this pond is up here on the top of the hill. And that water in the pond really wants to go into the ground, and it tries to seep into the ground all the time. But the ground's made of clay, so it has a hard time moving through the ground. We know this. But because the hill has a kind of an out for the water comes down here, and eventually it gets low enough and says, hey, you know what? It's easier to come out of the hill sideways. And there was this area on the side of the hill that was always wet. And that's an example of seepage, where water is pushing its way or oozing its way sideways because it has trouble going down through the ground. This is an issue for us here in Georgia because we have basements. So water goes into the ground and has a hard time going through our clay. We have basements that are built of concrete, and we know that water will go into concrete. Concrete's very porous. So if we got a bunch of water hung up right here beside my house, the water basically is going to move sideways. It is going to seep into the concrete because that's the easier path to go. We don't want this situation. If you have a concrete basement, which all basements are concrete walls, and the water chooses to go sideways because it has a hard time going down, especially if we have clay in the soil, that's what's called seepage, and we wind up with water in our basements, which we don't want. It's also why homes in Florida can't have basements, because even though we are not putting water directly in the basement, it's going to seep through the concrete. It's going to ooze sideways through the concrete slowly. Now, this doesn't look like a big deal. I mean, this is, okay, yeah, the wall's a little damp, but this is a good example of what we mean when we're talking about seepage. A lot of times seepage doesn't result in a puddle on your basement floor. It's just a little bit of water. The wall ends up being a little damp. Now, if this was a finished basement, you have drywall over it, you have carpet, you have furniture. You might not ever know that there's water seeping into your wall, and that water stays damp, which can lead to the growth of mold, which is extremely unhealthy. So we have to do things here in Georgia to prevent this seepage of groundwater into our concrete walls. Here's one of the easiest ways to do it. We use a product called Drylock. Basically, it's a type of paint, but it's a lot more than just a paint. Just paint alone will not seal up concrete. You use Drylock, and it basically waterproofs concrete. It makes it where water cannot soak into concrete anymore. And this is what we did in the lab. I took a concrete block and I treated half of it with Drylock and the other half I left alone. And you saw this, that when you poured the water onto the Drylock part, it just stayed on the surface. It beat it up. But this water went straight into the concrete, which means it would go straight through the concrete eventually and wind up in the basement on the other side. Some homes here in Georgia, if they have problems with too much water getting in the ground, they have to take extreme measures. Sometimes they have to dig up around the house, and they have to put a impervious surface around the base of the house that will keep water from going into or even touching the concrete. A lot of new construction here in Georgia, you'll see this. You'll see this black paint on the exterior walls of the basement as the house is being built. And that's a type of Drylock. It's meant to keep any water when they go back in and they fill in the dirt. It's meant to keep any water from being able to go through the concrete. They'll also have complicated drainage systems so that when it does rain, we try to get the water away from the house, not even give it a chance to touch my concrete because I don't want to give it a chance to go into my basement. I did a quick search. I mean, this is just a real quick one time. This is companies in Atlanta that perform specifically waterproofing work. There's a lot of them because we all have basements. We all are built on concrete. It rains a lot here, and we have a lot of clay in our soil. So this is big business here because it is a big problem for us here in Atlanta. Not as much other places. Probably not very many waterproofing companies in Arizona. Not as much clay, not as much rain. This is also why downspouts from your house are always pointed away from the house. You never have these downspouts that put water in the ground right here. We never want water right beside my house because that's going to increase the chances that the water is going to be able to seep in through the concrete. Here's an extreme case. This is my neighborhood. Is pretty good hill back here, and when it rains, the water was coming down the hills and it was hitting the back of the houses. And it's a basement on the backside of the house, and it acted as a huge dam, and there was a ton of water in the ground behind all these houses, and it would seep into the basement. So what most of the people on my side of the street did was they built a special drain that collected the water back here behind the house, and it ran it through a pipe and got it to the street, to where I don't want water next to my house, because if I have water next to the wall of my basement, there's a chance it's going to seep in. Now, permafrost and the frost line, these two go together. So we know water gets in the ground, and we know that the top part of the ground is dry. Most of them, that's a zone of aeration. But there's always a little bit of water in the top because it takes time for water to infiltrate down to that aquifer. Well, if it rains and then it gets really cold, or it's snowy and water falls into the ground, seeps into the ground, and then it gets really cold, that water can freeze. Well, when the ground stays permanently frozen, like it does in Alaska or northern Canada, we call that permafrost. It's when the water in the ground stays frozen all the time, which means the ground is pretty solid. Well, we're having a problem, and this is one of the indicators of global climate change, that now the permafrost is actually melting because the temperatures are rising a little bit. And when that permafrost melts, anything that was built on top of it that at one time was thought to be on kind of nice solid ground now is easier to move. You see a situation like these where a house here in Alaska all of a sudden shifted because the ground wasn't frozen solid anymore. So permafrost is groundwater that stays permanently, hence the perma, frozen. The frost line, however, is a little different. The frost line is the depth to which water in the ground will freeze. This is not water that stays frozen year-round like it does in Alaska. This is when you're in Minnesota in the wintertime, any water in the ground is going to freeze down to a certain point. The further south you go, the lot more shallow the frost line becomes because it's not nearly as cold. In Georgia, we practically don't have a frost line because our ground very rarely gets cold enough for the water in the ground to freeze. So once again, why am I telling you about this? You're not necessarily always going to live in Georgia. And I want you to understand why the frost line is a concern. So if water gets down here into the ground and then it freezes, what do you know about water when it freezes? It expands. So if I have a lot of water somewhere around my house, I let water get in the ground of my house, and then it gets really cold, and that water then wants to expand. It's going to push on the ground that my house is on. I don't like my house being pushed because my house is not very flexible. And something like this can happen. This is a case where we had some freezing and thawing of the ground, and the house wasn't built to handle that. So the house buckled and fell apart. You tend to start to see it with cracks in the foundation, cracks in the driveway. It's not very dramatic. It's not like an earthquake happens all at once. It gets bent a little bit one winter and then bent a little bit more the next winter. So as a homeowner, if you live in Minnesota and you start to see these cracks, you got to realize, hey, my house is getting pushed every time the ground freezes because my house wasn't built below the frost line. Now these posts, not straight anymore. This is a house that was built up on stilts, and as the ground expanded, it pushed the posts, and now they're crooked, which means the house is now going to be crooked. The bigger issue, less with houses than it is with decks, because decks don't tend to be anchored as well in the ground. And when the ground freezes, the decks get pushed on a lot more easily than a big heavy house. There are all kinds of cases where decks have fallen apart because they get pushed and pulled. And you might not know it until that spring day when you go out there and try to get on your deck for the first time, and then it collapses because it's been pushed on by freezing water. That's a process called frost heaving. Frost heaving is that movement of an object. Usually we're talking about a house or a part of a house, like a deck or a driveway, when the water in the ground freezes and expands. And we obviously want to prevent that from happening. Here's the first thing. Don't let any water get in the ground near your house. Because if the ground is dry, doesn't have water in it, it won't expand when it gets cold. So that's always the first step. This is going to be a theme. We always want to keep water away from our house because it's no good. So here's something that can be done. Remember, the water has to get cold to freeze and then expand and push on the house. So if I build my house with a basement, my basement is always going to be kind of warm. I'm going to run a heater, or it's just going to have some residual heat from the house, which means my basement is going to keep the ground around the house a little bit warmer. This is why most houses up in New York, Massachusetts, places where they always have basements because they have to build down below the frost line to keep the house from being pushed by water when it freezes. So, easiest solution, build a basement, keep the basement just warm enough so that the water around the house won't freeze. You have to have the basement lower than that frost line. So long as the basement is built lower than the frost line, the water in the ground won't freeze because the water deep underground never freezes. So water down here doesn't freeze. So if you go deep enough, the water will stay as liquid water. Most basements are deep enough that you end up being below the frost line. Some places might be cold and have a really high water table. So what they have to do is they have to basically put the house on stilts and drill the stilts in the ground. So the water here can freeze and it can push around, but it can't push the whole house because the house is anchored below the point where the water can freeze and push on the house.